Ladies and gentlemen, please take your seats. We're about to begin. Thank you. Please take your seats. The show is about to begin. Thank you. Can you hear me now? All right, the topic today was bin packing. The way we see it, we already have a problem trying to optimize how we schedule workloads across the different compute hosts that we have. Today we solve that with host aggregates, with host profiles, trying to differentiate the workloads across, and trying to solve the issues of configuration and scheduling across of all of those. We can't do the same in smaller edge nodes, so we think that's one of the problems that we have to solve for. How do we slim down into fewer, more cohesive compute node configurations that can support more types of workloads? That probably requires a change in both the configuration as well as how the VNFs are being run. Um, that's one problem I see with bin packing. The other problem is this idea that if we're running in a space where we're mixing bare metal containers and VM workloads, who's responsible for scheduling? Um, can we do that? Can we mix VM workloads and the same bare metal servers where we're running containers efficiently? That's another problem that we got to deal with. There are some other ideas that people are talking about. I think a lot of it comes down to what can we do better with the scheduler. Somebody was talking to me about this notion of, would the scheduler be able to function better if it understood the intentions of the VM? And by that I mean not just intentions of sizing, but my VM is intended to last 10 minutes, an hour, whatever. Can it allow the scheduler to make decisions around, oh, I got this thing that has a GPUs. It's not intended for you, but if you're going to last 10 minutes, maybe I can put you there. Would that help? Is that a real problem to solve? I got some things in the Etherpads around, well, somebody puts a lot of things around OpenStack-specific challenges. I see a lot of the challenges we see has to do with the static scheduling, right? I think our schedulers work today based on where the VM claims they're going to need, but not necessarily what the VM is actually using. So there's a need for a real-time utilization that the scheduler takes advantage of. I don't know if that's in the roadmap anywhere. What else do we have in here? Somebody talked about cluster optimization. I mean, this idea of what Watcher does of reshuffling things around in the cluster, I think we're a long way from being able to solve that, right? That's only going to work if we can ensure that the VMs or the workloads are not going to be impeded function-wise, are going to be able to seamless transition so I can reshuffle things within the clusters. I don't think that's the immediate target I would suggest. I'm interested in understanding what are the problems you're seeing with scheduling, optimizing the scheduling to maximize the utilization of the resource. Because in the edge, clearly this is going to be a much bigger problem. Right? You can't waste. We have a lot of, in our large data centers, there's a lot of underutilized space. A lot of it happens because our VNFs claim they need 20 cores, and maybe they have reasons around that, right? They want to be the only one running on that server, and they're using 3 cores or whatever, and there's nothing checking on them and telling them, good, I can put other things in this server. That is not going to fly in the edge, right? We need to solve that problem. What else? Does anybody have any thoughts on or problems you want to solve related to bin packing?
Are you mainly focused on containers and VMs just in the control space?
No, I was really talking. I think this is more of a problem. I don't see this as a problem in the control plane. The control plane, you're controlling exactly what you want to use, so you're packing things as well as you can. This is all about the compute space. I don't know where the microphone is. I can't hear you. Let me find the microphone. Does this work?
I was just asking, a couple of years ago, I'd run across a project called OpenStack Neat that did essentially movement of VMs from one host to another based on utilization, just CPU, RAM, and I think it also looked at some performance metrics based on oscillometer data. So at the time that I saw it, it was somebody's graduate student project. I don't know if it's graduated beyond that.
I think Watcher has
Curious
a
if you're
similar.
familiar with that.
Yeah, Watcher has a similar concept, I believe. The problem with that is that you have some VNFs that make it really hard to do that because they're pinning CPUs, they're using large memory pages, so trying to move them is very disruptive. It doesn't really work.
I mean, my experience is that it's not some DNFs, that's 95%.
Yes. I was being most of them come with those kind of requirements where, and then they tell you they want to be resilient, and you can't, and moving them is a challenge. So to me, that's a problem that we need to solve, right? If we could solve live migration for those VNFs, or convince the VNFs that they can achieve the performance somehow without the pinning, then maybe we can get closer to solving for some of this. Because
so, we'll take just a minute or so to essentially moan about VNF vendors. Is that, and forgive me if there's any in the room, but that's certainly our experience is working with telcos is we see that many of those VNFs, exactly as you say, will say that they need whatever it is, 24 cores, which means they need a guaranteed box, and the SRIOV and CPU pinning and huge pages and numer awareness, blah, blah, blah. And until we're at a point where those VNFs are sort of decomposed or disaggregated, whatever the right word is, and much more kind of microservice architectures, that flexibility that you're talking about, live migration and those things, just doesn't exist. It's a real headache. And so we're still trying to convince telcos, actually talk to the VNF vendors and get them to write the VNFs for the infrastructure that as is, rather than top down. But it's a real challenge, right?
well, I can tell you that we did some experiments with SRIOV, and we can get that working with small disruptions. But you're going to drop a few packets while it's happening, and only if you're not pinning, right? But yeah, it's a challenge. I think that's a core problem we need to solve for this is a problem of trying to make the VNFs cloud native in a sense. Might help getting there. But the other big challenge I see here is that if you want to run container workloads as well as VM workloads, and I believe that you don't have a choice. It's going to be this transition period where they're going to be both for a long time. Who's managing that scheduling across? Because now you're going to have, if you're using Kubernetes, Kubernetes is scheduling once. If I'm talking about containers and bare metal, so
there is a third option, right? So you can use Nova LXD and use LXD as a hypervisor to run a container virtual machine. And inside there, you could stack your Docker containers. And because that's using Nova API, the scheduler is aware of it and aware of the resource usage. But it means that you won't get some of the kind of auto-scaling and sort of the features that you'd get with Kubernetes.
Right.
There's a trade-off. But you do get awareness of resource utilization.
The resource utilization. I think there has to be another path where maybe they're collaborating, if you sense, or there's always a disaggregation where you're giving Kubernetes a set of resources and you're giving OpenStack the other set of resources that they're all managing itself. But even in that case, you have the sense that in our case, what we were doing is the control aspects that run in a compute node are running in Kubernetes, even if the compute node is running KVM and straightforward things. So you still have that. Nova still has to learn about that. I think that's a small fix, but that's one aspect. But that doesn't give you that overall vision of scheduling across and trying to optimize this across the two different boundaries.
You're ultimately going to have two schedulers, right?
Well, yes. Now that there's this thing that we don't really understand. I've been asking around, and nobody's giving me a straight answer as, does anybody see use cases or a real need where there is some affinity between the container workload and a VM workload that are part of the same VNF on the same host, forcing you to now have tenant container workloads and tenant VM workloads running on the same compute host. And that's a whole other nightmare, right? Because that opens a whole other challenge. Because at least with the other ones, you can separate Kubernetes one side, the OpenStack stuff on this side. But with this one now, they're really mixed together. They're sharing the same set of resources. I haven't gotten a straight answer. I've had asked a few VNF vendors if there's any reason why that would ever be a need. And they're talking about layer 2, but I think we can do that across a different compute host.
Sorry, to that particular point, doesn't it at that point land to the application deployer to provision a VM and run the tool?
I can't hear you, sorry.
Sorry. In the use case you're proposing where you have a container sitting right next to a VM on the same...
I'm not proposing that. I'm asking if anybody's heard of such use case. But go ahead. Ask your
I
question.
was wondering whether that's not something which the deployer can just handle by themselves. Provision a VM and run a container in it, and you got everything in one place.
Provision a VM and then a container inside the VM. Is that what you're suggesting?
Provision a VM, run some part of your workload, and there provision a container
Well,
in there. as well.
the one I'm... Yeah, that's
If
not...
there is such a use case. I assumed you were saying there was a use case, but if that's...
The notion, what I was thinking was this notion of, the VNF today are expressed as heat templates, right? And most of them, at least in our case. And how are we going to express those things when are we going to have heat resources that are going to, if somebody comes with a VNF that is expressed as these are partially VMs, and this part of my VNF is a container, and I say we write some resource types and heat that talk to Kubernetes and spawn those things up, then your problem of the mixing the schedulers comes into the picture, right? Because now you're trying to use the other option is that now your VNF has to describe it above in two different ways, right? I'm using heat for the VM part of aspects of it. I'm using maybe Kubernetes artifacts to describe. I know that some people are using via Tosca above and Cloudify to separate things, to create that abstraction above.
So if it's a hypothetical use case, I think we've spent enough time on it. I thought you were
No,
positioning that
no,
was an actual
I'm fishing to see if you guys have heard of them. That's...
Service chain would be an example that might be VM container scenario.
Well, I see VMs and containers happening. The question is there anyone that comes with requirements that requires a co-location of them in the host? That's what we don't. I don't want that. I don't want it. Hope that nobody wants it.
Yeah, but this is the real world that in the transition to more and more containerized DNS, that the industry will have legacy things sitting in VMs, which is the real case.
Yeah.
But in order to fit the density or the new requirements, we'll have to have containers as well. So I think it's, coming from a provider, from a user perspective, we assume that this will be the case.
But are you expecting? I'm expected to support that by having a server that I'm maybe configuring as a Kubernetes cluster node, and this other server next to it is running is a compute node for Nova, and they're talking to each other for the networking.
We cannot even afford that. We have a case that we have one host, and we have to have a VM for something and a small DNF in a container, and we have to find solution. And okay, Kubernetes is not the case there because it doesn't make much sense or it's not mature for networking and service chaining, but we use Docker and libvirt and trying to bridge them. So I'm just expressing that from user perspective, there is the need, there is a real requirement for that.
So you're talking about a scenario where I have a single server, I don't have a choice, right? Got to put them in the same place.
Yeah.
Okay. What else do we have in here?
You have to do phases though. You can say start out without that.
Well, yes. I think that's our approach, right? Try to start with the separation first. But you're right, in the smaller, yesterday what I heard was the smallest thing that most people was expecting was 3 to 4 servers. But even there, I think you still have this problem of, I can't afford to have each server have a separate purpose, right? Or unless because then maybe you're scheduling before you're scheduling your capacity management that this server is going to take this type of workloads and this one, and that's very weak, I think. So how do you do the? We find ourselves with this problem. We have all this capacity that gets diluted because we have to create aggregates and profiles that are all so different because of the VNF needs. Do you run into that problem too, or have you found a way of combining things so it's all a single profile or as close as possible to a single thing?
We, if I get the question, I think we have a single profile for both because we manage the whole thing. So we can provision that in the way that we want beforehand. It's a little bit more static.
So you run into the problems that if you're running Contrail or you're running SRIUV, then you don't want it to share the, or things like that. No?
We haven't run in that case yet, but potentially they come up.
So in the edge cases, in your what scenarios you guys thinking that what would an edge profile look like in your you think? Do we have do we understand enough to know that? No. I think that's something we should go define, right? What are the the profiles that we should be targeting for the edge?
What do you mean by profiles?
By profiles, what kind of workloads? We call a host profile the way we configure a server, right? So if we need to do, if we know that there are going to be a bunch of VNFs that need to do CPU pinning, then there's a pre-allocation of what set of the cores are for the pinning of the VNF versus used by the operating system versus used by orchestration components and so forth. If it's going to run SRIOV, there's a profile that will define how many virtual functions we're going to expose on this particular type of host, things like that, right? Or it even goes down, the profile might tell you, sometimes it goes down to versions of libraries because Contrail needs something or somebody else needs something specific. That kind of stuff. So that creates a lot of differentiation and makes it really hard to optimize what you have, right? Because now you're creating this, you're going from this size of things to a bunch of little buckets that only fit specific things. And that's not going to work in the edge, I would think.
Yeah, it's from our perspective, it's very difficult, and potentially, if you have a lot of workloads, they will start competing to each other. So we are in the beginning of this journey, and we have only few. Our ultimate edge platform will host just a few functions, so we don't see much of a competition on that. And if we start putting more workload there, user workload maybe, but especially if we assume containers, that problem will rise. So I think it's an open one. And the only way that we try to see that is with orchestration. So you mentioned again Tosca. We are trying to go to that direction because of the heterogeneous thing.
Mm-hmm.
Workloads and the SDN controllers. So you have control domains, different ones, and you need something
Something above.
on the top for the workloads only, and you need something else for the platform only. So we see that as a multi-control and orchestration problem.
Still doesn't solve the problem at the edge, I think, right?
Sorry?
The problem was the dilution of your capacity at the edge. No.
That doesn't solve it because it's something else. Yeah.
And is there anything in the roadmap of OpenStack for real-time, the scheduler taking into account the real-time utilization on the compute nodes? Do we know? Does anybody know? To improve the scheduling, we put that as a.
Doesn't the heat calorimeter and heat working together, don't they coordinate? Okay, there's not enough utilization.
Speak on the microphone, then we can hear your question.
I'm novice technically.
That's okay, go ahead.
All right. So doesn't the oscillometer and the heat work together to decide if they need more VMs or if they don't need, shut it
You're
down?
talking about auto-scaling.
Yeah.
Is,
There's a blueprint for Nova real-time instances, but it looks like it didn't make it past Mitaka. Well, looks like it has a partial implementation. So it looks like there's something there. Just completed in 2016. libvirt real-time instances. That's different. Okay.
I was hoping you guys have the answer.
Oh yeah, they should know. There's the Nova team
Yeah.
back there.
Well, not just rebalancing. It's also that I'm talking about the scheduler making decisions that are not just based on the flavor sizes that are being defined, but also what's actually being used.
Yeah, so real-time instances was a while ago, so I might get the fine details wrong. But my recollection is that was I'm a VNF and I have hard real-time requirements, so I want to be able to fiddle with the the CPU that I'm pinned to and stuff like that.
Yeah, it's more about like the instance gets configured to be dedicated a share of like an actual time slice of hardware so that you can guarantee it will run for X milliseconds per time cycle and stuff like that. It's all on the compute box. It's all
So that's different. That's more of a resource.
So what you missed out on while you were selfishly peeing,
I apologize.
yeah, don't do it again, was they were asking if there's anything on the roadmap to update the scheduler's view of resource availability in real time instead of
Just
having
for the initial scheduling decision to put it on
so-
cooler compute nodes.
Yeah, not real time in the sense of
it's
you know,
a
hard
feedback,
real-time instance.
using a feedback loop, essentially,
We
right?
removed that thing.
Look, I'm just throwing you under the bus, man.
Yeah, yeah.
What you do now is up to you.
I mean, there have been a couple of attempts at it, and we've removed them all, I think, at this point. Like the extensible resource tracker thing was that, right? I want to schedule on the CPU with the lowest fan RPM, and I report that thing in, and I schedule. There's still CPU metrics, which might be some of it, and you could write a filter that would schedule against that, but
I think they're more asking about their view of available resources in the cluster being laggy compared with actual use, if that makes
you're
sense.
not talking about like choosing the coolest compute node to put new things on?
No, we're talking about making decisions. It's a form of over-allocation to use the capacity better, right? So the VMs are asking you, I want, like the example, they want 20 cores, but when you look at the utilization, maybe they're using 10 only. And maybe it's not a guaranteed 20, so we want to give you something that tells you it's okay to put something else in there because you thought there were 20 in use, because you allocated the thing, it's actually 10. Maybe we have more space to put other things.
But isn't that just, I mean, what?
Yeah.
Oh, no, I understand. I'm just saying cooler is one particular thing. I mean, but you have to know in real time what the actual utilization is right now.
Right, over a period of time, yep.
Which is going to be wrong in 10 minutes when they spin up their thing, right? I mean, they're currently only using like half of their capacity, so you decide to put something else there, and then they go and like start doing a lot of
And that fits into this other notion, which is the intention of the workload.
Yeah.
So if the workload told you, and the edge, somebody was telling me there's this notion that the workloads are bursty, right? Some of the applications, the workloads will come, will last 10 minutes and they're gone, or they'll come, they'll last an hour, they're gone. So if you were able to get that information from the workload together with the real-time thing, then you can make decisions saying, oh, what's running in there right now is running, the capacity allocated is X, but it's running at Y, and there's this underutilized piece. And based on trending, maybe I can figure out that that's saying, that's coming in and asking me for space, could run in that capacity because it's going to be gone in 10 minutes.
It's still the same problem. It's just whether or not you're optimizing for putting somewhere hot or putting somewhere cold, right? It's still the same feedback loop.
Yeah, I think the punchline here is I haven't seen anything on any roadmap that says, for instance, when you launch an instance, tell me how long you're going to have it for, and I'll make assumptions about what to do after that, because everyone lies, right?
That's the point, right? Lying in a bigger region, it's maybe not as bad as you're lying on the edge, where you have a very limited capacity.
So I think if I was going to build something like that, what I'd actually do is I'd have a service outside Nova that understood the relative priority of the instances, and if I wanted to schedule something higher priority, I would go and kill low priority things and schedule the thing that was a higher priority. And you know what? If low priority things claim they're using more CPUs than they actually need, they'll learn over time that they should trim their resource request to be less aspirational.
You would hope that's.
Yeah, I think in general, it's weird that I'm talking to you while not facing you. In general, kind of my view is as much as humanly possible should be outside Nova, right? Nova is deliberately constrained because of its complexity. If a feature can be trivially expressed as something that calls existing Nova APIs, it should not exist in Nova.
Especially when that thing is very workload specific, right?
Yeah. So Google does this,
So,
right?
so you're saying that this thing is managing outside. It will decide, well, I want to put this thing here, so I'm getting the data that we're talking about, and I'm going to make the decision that I'm higher priority for this thing. I'm going to kill this other thing.
In
and
fact,
start
I
the
would
other
probably go and see if Congress does this already, because it does similar stuff. Like Congress lets you say, I don't like my virtual machines sharing a hypervisor with, that guy's virtual machines. I don't know why. Maybe he's uses a lot of disk I/O and it affects my performance or something. And Congress is this external thingy that you express these rules and then it goes and alerts you when they're being violated. And you would have to go and then make the relevant Nova calls to unviolate those rules. But Nova's not doing that thing for you. It's like a layer on top. Because the way you would express those rules and your needs are completely different from, say, Hadoop, big data things where they've got tens of thousands of machines, right? So instead of Nova trying to solve every single problem, what we do is we provide generic APIs and then let you slap a layer on top that is specific to your business needs. Does that make?
Is that going to cause latency? I mean, because you push that problem of the decision making to the kind of policy engine, in principle.
Yeah.
So that will not be. I mean, you'll add on latency. You wouldn't.
Latency to responding to a situation, you mean? Well, if Nova doesn't respond, the latency is infinite.
Yeah.
Right? But if you do it, it happens.
I'm also going to play with your definition of latency. So the question was, doesn't having an external service do this add latency? Yes. But the Nova latency in this case is we will land that feature in 3 years' time because the Nova team is too busy. So do you, especially like a whole bunch of Nova people have been laid off recently, right? So the reality is the team is much smaller than it used to be. It tends to work on things that are because they're on fire for existing users. So your choice is, do you want this feature before the heat death of the universe or not?
Well, and if we can add...
Well, the other question is really, do we need it? Because at the end of the point is, what do we need to do to optimize the placement in the edge, right? Because I think it's a little more extreme the need than it is on a regular region.
And if we can add 3 APIs that allow you to
Is this the thing that we
do
need?
all this stuff externally, then you can do that for a long time, and we only spent time adding APIs to let you...
Yeah, and you can iterate as you learn how that thing actually works, right? Whereas if it's inside Nova, iterating is going to be super painful because we have to make sure that all of our existing users get carried forwards with you.
Yes.
Yeah.
But
in your context, ONAP would be able to do that.
well, no, actually, they're thinking more like Valet is going to be able to do some of these things, because the Valet team is also talking about this idea of their scheduler also tapping into Kubernetes as well. So having a single place that can make decisions that help Nova make decisions of the placement, and it could also apply the same rule business logic that's defined there to help Kubernetes make decisions about placement.
You know that you can write your own wayers in Nova, right?
Right. It's a scheduler, right?
Yeah, your own filter, I know.
But wayers, at least, is a way to plug into the existing scheduler without rewriting the whole thing. But it basically says, okay, I've generated a list of hosts that are possible to put a thing. Now sort them for me and tell me which one's the best.
But that's how Valet works. There's a plugin, it's using that, so it gets its list, and then has a different optimization algorithm that makes a decision, and it goes back and tells you which one
Sure,
you
and
place.
maybe you can sort by the compute node that is the hottest and put it there, or you can look at the flavor that has been chosen, which means to you what the intent is.
Right.
Right. I chose a big I/O flavor. So therefore, okay, well, I'm going to pick, a CPU-bound compute node to put that on right now because this flavor to me means it's going to do a lot of disk I/O, not a lot of CPU. Sort that host up to the top and put it there.
Yeah, well, what they do is they allow you to express intentions by using other. They have heat resource types to express other kinds of intentions, and then they're behind heat, so that the heat gets a request. They know that this thing came. They look at the whole heat stack, and when it gets to Nova, eventually it also talks to them, and then make the decision, looking at the overall heat template, not just at the Nova resources, but what Cinder or Swift or whatever, all the kinds of resources they needed. Right. And then based on that, it tells everything, what decisions to make. And now they're talking about extending that to Kubernetes as well by plugging in their own scheduler, which is a feature of Kubernetes. You can write your own scheduler on it.
And I think this is kind of what we were trying to say, or at least what I was trying to say yesterday. Theoretical conversations are cool and stuff, but if people can tell us what they're actually doing now and the problems they actually are experiencing, then we can be like, oh, that's interesting. Have you considered doing this thing? Instead of, well, I'm just, I want a feature request on a roadmap. Well, maybe we can do it now if we can just refactor your problem a little bit.
Right.
But if we don't have concrete use cases like I'm a Comcast set-top box or I'm whatever this Verizon thing is or whatever, then it's hard for us to answer questions because it's all theoretical.
Right.
So I'd rather concretely know what product are you going to ship in the next 12 months and what does it look like and how can maybe we can tweak what's your actual problem and can we tweak the implementation to meet your needs without having to write a whole heap of extra features.
I don't know that we're necessarily there at this whole conference today.
There's one box that's using OpenStack.
Yeah.
Used in the field right now, research. They've done OpenStack plus for 9 months.
Oh, you're talking about the.
That's a real world use case where they're actually implementing code that some of it is being upstream and some of it.
There's a few of them, right? But like Verizon has this box, there's that canonical orange thing, whatever it's called. It's possibly yes. But none of those guys have come to us and said, I cannot do my thing. They've all been possible, right? No one's actually filed any bugs that say, and the orange box catches on fire when we try to do blah.
The orange box is just a component that you would build a thing that might have some requirements, right? The orange box by itself does not have any particular scheduling requirements. It's when you put 4 orange boxes, 2 in San Francisco and 2 in New York, that you then have scheduling.
The orange box is just a small private cloud.
Right.
So you haven't heard any density requirements, improvements that impact the scheduler, is what you're saying? Well, scheduling.
I mean, we hear things like that all the time, but none specifically.
Specific from the edge case is what I'm referring to, yeah.
But it seems like also from my experience, when people want to they just over-provision their boxes. They feel like their boxes aren't getting utilized. They just up the number of.
I think it comes down to that everybody lies statement. Everybody,
and the other thing is, I think private clouds in data centers are so happy with their utilization with OpenStack that they're not even thinking like that, right? Like the last big corporate environment I worked in before OpenStack, we had 25% utilization of our real physical hardware. If I'm getting 40% with OpenStack, that's still way better than what I had before, right? Because it's rooms and rooms full of machines. So they're not super fussed by wasting half a machine. I guess the CFO is, and he'd tell you he is, but it's still way better than what they had before. So, this edge case where you're super duper hardware constrained is not a thing we've really encountered before.
And it's also, some of these requirements of you almost have a single tenant because you're just using this to distribute your own workloads everywhere are very incongruous with what some of the people that are running a public cloud want out of Nova and its ability to manipulate where.
What do you mean a single tenant? What do you mean by that?
Well, I just mean if you are. Some people use OpenStack with one tenant where they're just using it as IaaS for the one kind of internal consumer of I want to put a thing here, I want to put a thing here, which is a very different scheduling problem and a very different kind of giving the external user control of where something goes than a public cloud where they don't want them to ever know where something is,
Yeah, think of it as a trust boundary, right? So single tenant is I wrote all of the stuff on all of the instances that we're scheduling and I trust me. just run it. Whereas multi-tenant is, that guy.
No, I know what
public
that is.
cloud,
I meant
God.
what you meant by this in the edge cloud. I mean, that's not scenario. That's not how it works for us.
Yeah,
There's
some people, the whole edge concept is to let other vendors run stuff at our edge or something, but it's not for everybody, right? Like,
Well, think of it as this one. So the edge functions are different services are being provided. Each service is being managed by a different organization. They have their different funding. So yeah, they're different customers, even if it's all the same company.
sure,
So,
but the
so you're still managing as a multi-tenancy.
the trust of Rackspace letting Coke run something in their cloud is very different than, Verizon letting one business unit select a thing that goes over here. I mean, there's definitely a different level of trust there.
But if you look at the model that they were proposing yesterday, they're talking about sending workloads up from phones to edge nodes and then running workloads.
Sure.
That,
But I think it,
workloads still may be
yeah.
controlled by the,
But it's about who wrote that workload, right? Like I have an existing process inside my company. If you muck around on my private cloud, I fire you, right? I don't need additional layers of business logic. I can fix that already. In the same way that, if Huawei's got a little What's-it on their phone that wants to push up to a bigger box to process something, Huawei controls all the software, they control both ends, they deal with that outside of OpenStack.
Can I eat my Rice Krispie treat?
No. Wait, there's Rice Krispie treats?
There are.
Session over.
All right. Does anybody know or have another use case or problem we need to solve for the edge in terms of optimization? Kasim, you were talking about something to me earlier. What was that? Put you on the spot. Go ahead.
I also think it's useful to talk about not just compute resources, but when you talk to the NFV people, they seem more interested in pushing a ton of data through their network stack there, and so how you allocate and provision the network stack, and manage those resources effectively, or even someone talked about too, like how do you optimize storage? Like if you're content distribution, right? Maybe compute isn't the limiting thing on your box. It's how do you pack the storage in and decide what storage is going to be vacated so that new media can be placed there to cache locally. So I mean that seems like it's looking beyond just the compute model.
So how do we optimize storage? So what are you guys planning to do on the tenant side storage? Today, what we do on the non-edge is very prescriptive, right? The storage is large buckets of storage that get presented to the compute host. Now, we do want to move to what we're doing with a control plane, where we're using an SDS, essentially, with Ceph. And we want to get to that as well. I think that'll give us a lot more of this flexibility you're talking about needing. But we're not there yet. We're trying to get Ceph first in the control plane so that it can be operationalized and accepted before we go into the tenant space with that. Is anybody here using Ceph already for the tenant space? Storage? Or do you guys use Ceph? I think I heard you talking about Ceph and the other talk. Did you use it for what? For the control plane, or are you using just? You were using it as a backend for Swift, I think, is what taught you, or?
Well, we use it a lot for we use it for projects as well. We can always use Swift if the customer has a preference to do that.
So for tenant, for the VM data storage, you using Ceph. That works well for you? Did you have specific storage problem that you wanted to talk about? What's his name? Chris?
No, that's just what I was trying to feedback on things I heard.
The storage problem? Is it a problem? And if you're using Ceph, do you see it as a problem to solve for the edge?
We talked about this. The problem is that, no, the problem, a feature of that is that you need 3 nodes, really. So
Right, the quorum.
you may not have 3 nodes at the edge, right? So you can run 3 instances on the same machine, but no.
But that becomes a question of, if you have a small enough node and you can't reach quorum because you don't have enough node, then is it about a loss of resiliency that is acceptable in that single node site? I mean, what else can you do? It's a single node. If the node dies, it's dead anyway. But yeah. Right. But still the same problem, right? Still goes, storage goes. Yeah, I don't see that one as a... You talked about the network too. How do we optimize the network? Are you talking about, when you're talking about the data, you're talking about the images for the application? Or? That's all. That seems to me like it's a whole slew of different things, right? It's almost in the realm of the CDN type notion, right? Are you using a CDN to cache what these applications need, and using some global load balancing to present it to the edge to get to the right cache? Typical CDN problems. I would, yeah. We have here the network. I'm not sure what specific network problem you're referring to here. The network configuration, the network traffic delivery, or? In my mind, that problem seems to be equivalent to what we do today to some degree, right? And at least what we do in the D2 domain in the medium space with the VNFs, it's a similar problem of capacity managing the bandwidth and the flows per second and things like that. That suffer from the same problems to some degree that VM creation suffers. Although there seems to be closer to reality, right? When I tell you this thing is going to do certain bandwidth BPS or whatever, it tends to be more real than when they tell you I need 20 cores. So how we want to manage that is very prescriptive, I think. Right? The network is built with a certain amount of capacity, and the VNFs are deployed knowing. I think you're right. It is a different problem because here most of our VNF are long-lived. They come, they live a long time. They tell you what their BPS is, whatever their packet flow is going to be, and you can do capacity manage around that. But here, this is going to be, I think, more bursty, and in terms of And by bursty, I mean applications are going to fluctuate more. So the bandwidth needs of the application is going to be more of this package thing. I think Steve was talking about this yesterday when he was talking about like the IoT use case, not understanding what those things will be. If all of a sudden, I guess it will be parallel to, when the antivirus software used to wake up and go and everybody try to get the same update at the same time, versus you have all these things that are connected and not doing anything most of the time, but then they all wake up at the same time. So you're going to get this need to deploy these things, this huge burst, and go away. So you're right, it's a different challenge. How do you engineer the network to survive those things? And what's going to be able to look at that network availability to make some of those scheduling decisions as to what's the right region for that edge thing. That's a whole topic. Maybe we can touch on that in the network discussion that they set up for this afternoon, because that's a good problem. And I don't know, somebody put here, can it be managed with existing technologies? I don't know if you can allocate more capacity. You already allocated capacity. It's going to go to that edge. It's really a scheduling thing. How can you schedule a scheduling above that's deciding where this thing goes on the edge. That's going to take into account that almost a real-time network utilization at a given point in time to make decisions about which edge to send you to, I would think. Something like that. We don't do that today. That's a good problem. All right, does anybody have anything else? Any other topic they want to follow up with? No? All right, thank you very much then. I think we're done.